Hello students, I have come up with one more NEET problem, expected NEET problem this year 2025. The problem is find the minimum force parallel to the plane, how much force I need to give to the block parallel to the plane required to just move the block up the plane. The frictional coefficient between the block and the incline is nil. Question ये है कि how much force I need to give to this block so that it just moves up with constant velocity. Means I have to apply minimum force. If I apply force more than that, more than the minimum value, so it may accelerate in the upward direction. But I have to apply minimum force so that it moves up. So, what are the possible forces acting on the body barring this F? इस F के बगैर और कितने forces इस पर है? तो mg acts downwards, that's the weight of the body. Put this into two components, it is theta, because this is theta, this is also theta, and this is mg cos theta, this component, and this component is mg sin theta. तो दो कंपोनेंट इस फोर्स के हुए mg cos थीटा और mg sin थीटा, लेकिन इस mg cos थीटा की वजह से द बॉडी विल प्रेस द इंक्लाइन, इस इंक्लाइन को प्रेस करेगा बॉडी, इसलिए द इंक्लाइन विल प्रोड्यूस ए नॉर्मल रिएक्शन इन दिस डायरेक्शन परपेंडिकुलर टू द इंक्लाइन. एज देयर इज नो मोशन परपेंडिकुलर टू द इंक्लाइन, इस इंक्लाइन के परपेंडिकुलर डायरेक्शन में कोई मोशन नहीं है, इसलिए इस n को आप mg cos थीटा के बराबर लिख सकते हैं. तो पहली बात यही है कि स्टेप नंबर फर्स्ट, n इज इक्वल टू mg cos ऑफ थीटा, राइट. नाउ एज देयर इज नो मोशन इन दिस डायरेक्शन, द मोशन इज पॉसिबल ओनली अलोंग द प्लेन. तो आपने इस f को अप्लाई किया तो द बॉडी टेंड्स टू मूव इन द अपवर्ड डायरेक्शन. So when the body tends to move in the upward direction, there's a frictional force which is downwards. So what are the second step? What is the total downward force along the plane? Total downward force F down is equal to mg sin theta plus frictional force. So that's equal to mg sin theta plus frictional force, as you know, that is mu n. Again, it is mg sin theta plus mu n is equal to mg cos theta, mg cos of theta. So these two forces, some of these are acting down the plane. So how much this force should be so that the body moves up the plane with constant velocity? So it becomes very simple. So F applied is equal to F down, that is equal to ये फोर्स जो है जो मैं अप्लाई कर रहा हूं, ये इन दो सम ऑफ द टू फोर्सेस के बराबर होना चाहिए ताकि बॉडी मूव करे अपवर्ड्स विद ए कांस्टेंट वेलोसिटी. So if you apply force more than this, then the body will accelerate in the upward direction, which I don't want because I need F minimum. So it is mg, कॉमन इन दो को निकालिए, sin theta plus mu cos of theta. That is the answer. This much force you need to apply. So it was a very simple question, but it involves frictional force, it involves equilibrium of forces, because the body needs to move up with constant velocity. When body moves with constant velocity, you must know that it's an equilibrium, dynamic equilibrium, where the net force is zero. So again, it is a mass m on the block. The question is how much is the applied force so that it moves up slowly with constant velocity. There are two forces which are in the downward direction, mg sin theta along the plane down, and there's also frictional force which is downwards. Frictional force is downwards because the body has a tendency to move up. Therefore, this applied force has to be equal to sum of those two forces, mg sin theta and frictional force, that is mu n or mu mg cos theta. Thank you.